Okay, can I have silence? Take a look at question number 12. Part A, writing now cosine ACD. ACD is an obtuse angle over here. So we cannot simply apply using your adjacent over hypotenuse. We need to rewrite this to become negative cosine ACB. Okay? So you know that your cosine theta equals to negative cosine 180 degrees minus theta. And over here, if we let theta to be ACD, 180 minus theta will be ACB because they are adjacent angles on a straight line. Alright, now we are able to find out cosine of ACB with adjacent over hypotenuse. Okay, so negative 8 over 10. Answer is negative 4 over 5. This is the presentation. Okay, any questions? No, then let's go on to part B. The perpendicular distance from B to AC. So we can let perpendicular distance be D. So we can use what we have B to AC. Or we can actually use the area of triangles. So half times 10 times D is equal to half times 6 times 8. So you get the answer for D quite easily. Okay? So just 1 mark only. Okay, thank you. Any questions? We're going to get the answer ourselves. Okay? Next question I want to talk about is question number 17. Also on paper 1. Question 17A. Okay, I'll go through part B also. Find the speed of the car when t equals to 15. When t equals to 15, if you look at the graph, it is part of a straight line. The gradient of a distance time graph gives you the speed. So since it is a straight line, we calculate the gradient, which is the speed. So speed equals to gradient. And we have 400 minus 100 over the time taken, which is 25 to 10. We get 300 over 15. Answer will be 20 meters per second. Okay, this 20 meters per second applies for time between 10 to 25 seconds because it is a straight line. Now part B. It is moving at a constant acceleration for the first 10 seconds. And the acceleration formula is given by Ipin. What's the acceleration formula? Ipin. Acceleration formula. What is the formula? What? Distance over time gives you speed. I'm asking for acceleration. Wrong. Does it ring a bell to you? Or is this the first time you are hearing it? Okay, so final speed minus initial speed over time taken. What is the final speed? For the first 10 seconds, what's the final speed at time equals to 10? Ikpin. Ikpin, what is the speed at time equals to 10 seconds? What? Why 100? Why? What is the distance traveled? What's the time taken? So you are calculating the speed for the first 10 seconds, is it? Is that how you calculate it when there is no constant speed? Look at part A. What did they ask for? Part A, they're asking you for the speed when time equals to 15 seconds, right? Then you notice that from time equals to 10 to time equals to 25, is there a constant gradient? So is there a constant speed? What is the speed? The speed is 20. So what is the speed at time equals to 10 seconds? 20. So that is the final speed at time equals to 10 seconds, right? Okay, so what is the initial speed now? Yes. What is the time taken? 10. So what is the acceleration? 2 meters per square second. So pay attention when I'm going through. Part A was required to answer part B. If you did not follow part A, how can you do part B? Now part C, draw the speed time graph. Yes, you can use from 15 to 10 because it is still a straight line. It is part of a straight line and it has a constant gradient. You will get the same answer. Okay, so now for part C, they want our speed time graph. So from 0 to 10 seconds, how much is the, until 10 seconds, how much is the speed at 10 seconds? Zikian? 20. Okay, so it is experiencing constant acceleration, right? What can you tell me about the gradient of the speed time graph? The gradient will be constant because the acceleration is the gradient of the speed time graph. So yes, we are getting a straight line. Okay, then what happens after that? After 10 seconds? Flat, yes. Don't just tell me it is a straight line because these are also straight lines, these are also straight lines. What you should be telling me is it is flat. A flat horizontal line because speed is constant after that. Okay, so draw a horizontal line. Okay? Until 25 seconds. Any questions? Okay, then let's go on to number 18. Part C. Write down a possible equation for this graph. Those of you who have your papers, right, how many of you just wrote this? 2 power x. Did you write that? Yeah, like what Vincent said. This is not an equation. This is like a term, it's an expression. An equation must have something equals to something. So what you are trying to tell me is y equals to 2 to the power of x. Is this the only answer? For some strange reason, right, by coincidence, almost everybody got this answer. Y equals to 2 to the power of x. When there are so many other possibilities, for example, y equals to 3 to the power of x. Y equals to 10 to the power of x. All these are possible values because they have the same shape. Okay? And all of these, when x equals to 0, y equals to 1. right? And you can see that in the graph, the y-intercept is 1. So all these are possible results that we can have. Okay, you'll notice that the 2007 paper, right, there are quite a number of questions that we don't really have to do. There's this little symbol at the side. Okay, so we are moving on now to paper 2, question 3. For example, paper 1, question 25, you see this lightning thingy over there? Then no need to do. Not in syllabus. Okay. Never mind. Okay, let's move on. Paper 2, question 3. Part A. You have a parallelogram and you have many lines that bisect the 4 angles of this parallelogram. Show that angle PAD equals to angle RCB. Okay. PAD. Let's identify the angles first. PAD. This angle over here equals to angle RCB. This angle over here. To show that they are the same, we are going to have to use the properties of a parallelogram. In particular, which property? Something about their opposite angles. Okay, tell me about the opposite angles of a parallelogram. Yeah, they're the same. Okay, so that is the property that we are interested in. So our first line will be angle DAB equals to angle BCD. So we can call this opposite angles of parallelogram are equal. Okay? Yeah, this is part A. So now the opposite sides are equal. Then we are going to have to make use of the information given. APQ is a straight line that bisects angle A. So we have angle PAD equals to half of angle DAB. This was given in the question. We also have angle RCB is equal to half of angle BCD. These two are given in the question. So now we can conclude that, therefore, angle PAD is equal to angle RCB. Shown. These two are given. What? What A? What are you saying? No, we are not asking for similarity or congruency yet. This is just showing that two angles are the same. Now part B is where you will need to consider the different tests. Because they are asking you to show that two triangles are congruent. ADP. So like what Ms. Tan said, sketch out the triangles. ADP. And then in the same orientation, since it's congruent, right? Draw an exactly the same one. So first one is ADP, second one must be CB and R. So now we are trying to prove that these two triangles are congruent. We have many tests that we can use. You have your ASA, SAS, RHS, SSS. These are the 4. Okay, so which one is the easier one that we can use? Just now we already showed that PAD in purple color this angle is the same as RCB. So we have a pair of same angles already. And then because this is also a parallelogram, we know that the sides, your AD is equals to BC. So we have a pair of corresponding sides, exactly the same length. So what will be the next thing that we can find? That is quite easy. Yeah, angle. Because now we have a side that is nestled between two angles, right? As long as I can prove this is equals to this, then I've shown that these two triangles are the same. They are congruent. So let's find out where this angle is. ADP. ADP. Okay, this angle, we are trying to prove that it is the same as CBR. CBR. This is the next thing we need to do. Prove that they are the same. And the method is going to be the same as this. The method, they are exactly the same. Because this line, DS, it bisects angle ADC. Likewise, the line BRQ bisects angle CBA. Okay, so I'm not going to work it out. Same method as part A. Then we use the ASA congruency test. Now, your presentation for the last line. Therefore, triangle ADP and triangle CBR are congruent. No, you can't do that. I've said it before already. So the things I want to draw your attention to is spell this out, spell this out, spell this out. Yes? Similarity, don't need write out. Yeah. So over here, by the ASA congruency test, okay? Yes. What is it regarding? Okay. Okay, any questions for this proving that they are congruent? No? So congruency test, you need to say by whatever test they are congruent. Similarity, you do not need to state the test. Okay, who needs me to go through C part 1? Anybody? If not, then I have one more question. Question 6. C. It's just a presentation issue. Almost everybody can do this, can do the calculation, can get a correct answer. But I have students who write this. Okay, read the line. Part C. The mass of 1 cubic meter of cement is 1420 kilograms. So what do you all think of this? What do you think of this line? Okay, look at it first, because I see some of this. This is the first line. Okay? How many of you feel that there is nothing wrong with this? How many feel that there is something wrong? Okay, Anjali, can you tell us what's wrong? Why doesn't it make sense? Okay, what are we measuring over here? Volume. What is this over here? Mass. Are they the same type of quantity? No, they cannot be equal. Your mass cannot be equal to volume. Rather, how you should write it is 1 cubic meter weighs or has mass 1420 kilograms. Okay, this is how you should be presenting it. What else I don't accept? 1 cubic meter, arrow, 1420 kg. I also don't accept. What does the arrow mean? When do you learn this arrow? In primary school, yes. In primary school, this arrow is taken to mean many things. But what goes through your mind is actually 1 cubic meter has a mass of 1420 kilograms, right? But sometimes you use it for 1 unit represents 2 kilograms. Or 1 unit represents 3 apples, right? Then you use the arrow. So if that's the case, you write down REP, RESENTS, represents. Why am I so sticky about this arrow? It's because, what subject is this? Mathematics. Symbols, they have meaning. And this arrow has a meaning in mathematics. It is reserved for something else already, okay, which is not in your syllabus. Okay, it's got to do with differentiation, limits. You go and flip your A-Maths textbook, you may see this arrow. Okay, limit. So don't use symbols which you do not understand or anyhow use them, because some of them are reserved already. So now, how should you present this? You should write it down this way. Okay? And finally, for part E. The price of each bag of cement is $8.50. This includes your 5% goods and service tax. So, 5% is GST. Okay, 5% of price, or rather original price. Okay, so can we say that 95% of original price is equals to 8.50? Or should we say 105% of original price equals to 8.50? Which one is correct? Number 1 or number 2? Who has difficulty deciding? Okay, so listen carefully. Both of them look okay, because you see that 5% is GST ma. So the question is, which value should be our 100%? Whenever we deal with percentages, we need to ask ourselves, 5% of what? 100% of what? Where is our 100%? So, according to the question, $8.50 includes 5% of your GST. So our original price that we are comparing this 5% with is the 100%. The 100% refers to the original price without your GST. Okay? So that is how we decide. Number 2 will be the correct expression that we are using. 100% is the original price. I slapped a 5% GST on it. So I reach a total of 105%, and this amount is $8.50. So from here you continue to evaluate and find out what is the total tax paid. Okay? So another common mistake for this type of question is, and I've said it before, I see this 105% equals to 76.50. This 76.50 is from $8.50 times 9, because there are 9 packets. Okay? So 105% equals to 76.50. Can or cannot, Run Chen? Can or cannot? You do not have to calculate anything yet. Just tell me whether this underlying equation is right or wrong. Yes? What's wrong with it? What's wrong with it? So I've seen this more than 3 students wrote this. So what's wrong? Run Chen? Who cannot see what's wrong with this? Okay, I want you to take out a calculator. Where minus? No, this one is equal. I'm just telling you that this is equals to 8.5 times 9. Okay, I want you to take out a calculator and tell me, how much is 105% in fraction? In fraction, how much is 105%? 105 over 100, right? 105 over 100. How much is this fraction in decimal? This is 1.05. Can you see that this 105% is equals to 105 over 100, which is equals to 1.05? Right? These three, they are the same thing. Exactly the same. Brian, do you agree? Exactly the same, huh? Now, is 1.05 the same as 76.50? No, they are not the same. They are different. By how much? By $74 and, I don't know, $75.45. There is so much difference. Okay? You cannot write 105% equals to 76.50. How should we write it then? Yes, it is always percent of something. 50% of original price, 20% of original price, 10% of a cake. There is always a second portion which we conveniently leave out. So it is 105% of original. And usually we let this be x lah. Okay, so this is equals to 76.50. And we will write this down to become 105% times whatever it is, original, equals to 76.50. And then we continue to work it out. And we find what is the original. Okay? So don't make such presentation mistakes, because this will definitely cost you marks. This is mathematically inaccurate. This part is wrong, huh? Mathematically wrong. Even though you know what you're doing, but it is wrong. What? Now you know this. Now you know the correct one. Why you still want to consider? Yeah, because you've been writing this too frequently, right? So now, don't do it. Okay, practice from now on. Okay, last part is question 11b on probability. B part 1. You have a pack of 16 cards, 4 cards of each color. Okay, so 4 red, 4 blue, 4 green, 4 yellow. Each color has 4 numbered cards from 1 to 4. And then you shuffle it and you draw a card. Find the probability that it is either a red card number 4 or a blue card. So we draw a partial tree diagram. Let's consider red card number 4. So first you need to draw red color, then you need to draw number 4. What is the probability of this branch happening? What's the probability of drawing red color? 4 out of 16. In other words, 1 out of 4. Okay, so 4 out of 16, which is the same as 1 over 4. After you draw a red card, after you choose a red card, then what is the chances that out of that this card is number 4? Okay, given that it is a red card, what is the probability that it is number 4? 1 over 4. Because red cards, you only have 4 numbers for red card. 1, 2, 3, and 4. Out of these 4, you choose one card at random. What is the probability that it is number 4? 1 out of 4. So we have another 1 over 4 here. It is either this branch that allows you to get a red card number 4, or we go by another branch which is blue color. So what is the probability of a blue card drawn? Again, 1 out of 4, which we will just write as 4 out of 16 equals to 1 over 4. Yes, so probability of red 4 or blue equals to 1 over 4 times 1 over 4 for this branch plus this blue one, 1 over 4. So you get, yes, 5 over 16. Any questions? Then part 2. Part A, probability that both are yellow. Now, we draw 2 cards at random. They didn't say we are replacing, so I draw a first one. How many cards are left? Left 15 cards. Then you draw another one. Okay, so that is the scenario. So probability, both are yellow, will be probability first yellow and then yellow again. Probability the first card is yellow will be 4 of 16, which is 1 over 4. After you take one yellow out, we left 15 cards. How many yellows are left? 3. So probability both yellow is equals to 1 over 4 times 3 over 15. And we will get 1 over 20. Okay, so last part B. At probability at least one blue. Okay, now whenever you see probability questions and they tell you at least something something, you need to remember this point that I'm going to make. Consider using 1 minus probability something. Okay? So when they say probability at least one blue, consider probability 1 minus no blue. Okay? Otherwise, you have to list out many cases. So this is a one-step kind of working. Okay, so probability of at least one blue will be equals to 1 minus probability no blue. Okay? To find probability of no blue is probability no blue. First one is not blue. Then the second one also not blue. What's the probability? First one is not blue. Will be 3 over 4. Or rather, because I skipped that, 12 over 16. So after you take out one that is not blue, we are left with 15 cards. And it will be 11. Because you take out one that is not blue, you are left with 11. Oh, okay, so now probability that both are not blue is actually P no blue is equals to 3 over 4 times 11 over 15, which is 11 over 20. So 1 minus 11 over 20, you get 9 over 20. Okay? So that's all for paper 1 and 2 for 2007. Yes, these are the questions that I'm going through. So next thing that we are moving on to is this, your algebraic expressions and equations.